Hi everyone. I'm Steph, project manager and representative from Alpha & Company, and I'm here to present our market stability simulator. So to go right back to the start, we had our initial brief to build this market simulation using a multiprocessor. And this led to some initial split interpretations. Half of us looked at this and saw a stock market. The other half looked and saw an intelligent scheduler. There it is. So obviously we wanted to formalize this concept. We came up with approaching it from the background of an exchange for trading computation cycles as a commodity. Similar to Sanskrit Compute Utility, or GIMP's, the Great Internet Mersenne Prime Search. So for an overview, we have our computer scientists with a big NP problem. On the other side, we have lazy students with lots of spare computation cycles. And in the middle, we have a market to facilitate the trading of these cycles. For simulation, we want to abstract this down into an agent-based model. So we have our stochastic client, which generates random tasks. We have intelligent agents, which use strategy evolution to bid on the tasks and also trade with each other. And in the middle, again, we have the market, which generates, which facilitates trading and calculates indicators. Going back to the brief, the specification asked us to implement this on the Computer Lab's multiprocessor research platform, more affectionately known as the BEAST. Now this has quite an interesting topology, as you can see, from here and from here, which we obviously presented some implementation issues. On top of this, lack of support for Java meant we had to code in C, and limitations on memory size and bandwidth meant we had to restrict our chromosome length and our task size. On top of this, the piece of equipment itself and related tools are still in the development stages, so we came up with a backup plan, which was to emulate this network on the PWFs. Unfortunately, for a number of reasons, we had to go down this route, but we do retain the option of moving to the system when the relevant tools do become available. This brings me into our processor code, for which we looked at a number of alternatives for machine learning, including neural networks and genetic algorithms. And eventually, we settled on genetic algorithms as follows. Here we can use this thing. We have our beta parameterizing the market price, delta, which parameterizes the task size, and the final 6 bits, which indicate which processors we're happy to trade with. So the algorithm, we take a big random population of those, we assign them probabilities using a fitness function, we make a selection from those probabilities, we take certain bits and cross them over, we take more random bits for mutation, and like magic, we have a new strategy to go into the next iteration. The idea being that this process is repeated over and over, evolving into some optimal solution. So all this leads into our overall application, which we put to you as an agent-based market simulation research platform, with potential for expansion in certain areas, for example, making the system programmable, or using the system as a basis for a live exchange with real clients and real tasks. That being said, what I want to finish with is results from our current implementation. So as you can see here, we have 4 basic indicators: market price, logarithmic returns, volumes, they're volumes, and volatilities. And I will take a closer look at the market price. So here you have trends as expected, a bit of a price bubble at the start, a crash, and it eventually settles into an oscillatory motion towards the end. The yellow lines indicate the bids made by processors. So this gives some insight into how the genetic algorithm works. Another important metric, the total money in the system. This is the sum of account balances from each processor. One thing we noticed about this particular simulation, we made quite an interesting observation, for which any statisticians may want to look away now. You do some selective zooming, as here. You squint your eyes a little bit, and you start to get something that bears a remarkable resemblance to the FTSE 100 index over the past 24 years. And we'll think you'll all agree that this would make our project something of a success. I'll leave you with that thought, and thank you for listening.